Hello, for today's video lecture we're going to be talking about Newton's second law of motion. So Newton's second law of motion states that when a net force acts on any body with mass, it produces an acceleration of that body. The net force will be equal to the mass of the body times the acceleration of the body. Or more commonly in the equation form, how we talk about this is F equals ma. So force equals mass times acceleration. Alright, so F equals ma, we need to understand that this is the net force, as stated in the description before, or the sum of all the forces acting on the object. So we sum up all the forces, and that's going to be equal to the mass of the object times the acceleration of the object. So something like this rocket ship here, the net force that's going to cause the acceleration upward is going to be the force of the thrusters, but this is going to be quite heavy, so we're going to have to subtract off the gravity force that would be pushing down. So there's more thrust force pushing up, but we do have to subtract off that gravity force. Alright, so also important to note that these are vectors. So if everything is going in the same direction, we can kind of simply add them up as scalar values, but most times we're going to see that the vectors are pointing in lots of different directions. So here we've got some of the forces acting on this car as it accelerates. So we've got a normal force at each tire, a gravity force at the center of mass, and assuming this is a rear-wheel drive car, we're going to have a friction force pushing the car forward from the engine and the tires. Alright, so the acceleration would be going in this direction because of the net forces. So our normal forces here and here, and the gravity force here actually all counter each other out. What's left over is this friction force causing this acceleration. So the direction is going to be important in all of this. So vectors have both a magnitude and direction, which is going to need to be taken into account when summing up all of these vector values. So the sum of the forces is a vector value, and the acceleration is a vector value as well. Alright, so for rotation, we have something similar. So in addition to the similar F equals ma, Newton's second law can also have a rotational counterpart. So that is going to be m equals I alpha. So the net moment exerted on a body will be equal to the mass moment of inertia, I, times the angular acceleration, alpha. So for something like this top, if I know the moment I exert on the top, I know the mass moment of inertia of the top, I can figure out the angular acceleration on this top. Alright, so that's all we have for today's video lecture. Thank you for watching, and I hope to see you again.